Massive, Voyager found a 50,000-degree wall at the edge of the solar system. Something invisible is burning at the edge of everything we know. Right now, two machines launched before the internet existed are drifting through a superheated barrier that shouldn't exist. They're transmitting signals back from beyond the boundary of our solar system, and what they're revealing is rewriting everything we thought we understood about the universe. Because the edge of our cosmic neighborhood isn't empty space. It's a roaring inferno of plasma reaching temperatures hotter than the surface of most stars, and scientists are only now beginning to understand what it really means. Decades ago, twin spacecraft left Earth on what seemed like a simple mission to photograph distant planets. But they never stopped. They kept going, pushing deeper into the void, into regions no human-made object had ever touched. And when they finally reached the boundary where the sun's power ends and interstellar darkness begins, their instruments detected something that defied prediction: a sudden, violent spike in temperature. Not gradual, not subtle, instantaneous. From the cold of deep space to 50,000 degrees Kelvin in moments. Imagine crossing an invisible threshold and suddenly finding yourself surrounded by plasma hot enough to vaporize any known material. Yet somehow, these fragile machines survived. They passed through the inferno and kept transmitting. What they discovered on the other side changed everything. The data flooded back to Earth in whispers, faint radio signals carrying 22 hours across the void, each one containing measurements from a region that exists beyond maps, beyond predictions, beyond the reach of sunlight itself. And buried in those transmissions was evidence of a cosmic phenomenon that challenges our fundamental understanding of where our solar system ends and the galaxy begins. A boundary so energetic, so turbulent, that some researchers believe it might be the key to understanding why life exists on Earth at all. Because this wall of fire isn't just a curiosity, it's a shield, a protective barrier that has been deflecting lethal radiation from deep space for billions of years, creating the stable conditions necessary for planets like ours to evolve complex organisms. But here's where it gets disturbing. Recent analysis suggests this shield is weakening. The wall isn't as strong as it once was. The heliosphere, the protective bubble created by our sun, has been measured shrinking at a rate faster than models predicted. Some scientists theorize we're entering a galactic environment more hostile to life than Earth has experienced in millions of years. If the wall continues to thin, cosmic rays currently blocked by this superheated barrier could penetrate deeper into the solar system, reaching planets that have been shielded since their formation. The implications are staggering. Increased radiation could affect satellite systems, astronaut safety, even atmospheric chemistry on Earth itself. The probes that discovered this are now farther from home than any object humanity has ever created. Over 15 billion miles away, moving at 38,000 miles per hour, yet still taking nearly a full day for their signals to reach Earth. They're operating on power sources weaker than a refrigerator light bulb, with computer systems less advanced than a modern hearing aid, yet they continue gathering data from the most extreme environment ever studied. Every measurement they send back reveals something unexpected. Plasma densities that fluctuate wildly, magnetic fields that twist in directions that shouldn't be possible according to standard physics, pressure waves that suggest something massive is moving through interstellar space nearby, disturbing the fabric of the cosmic medium itself. And here's something almost no one talks about. The wall isn't uniform, it's asymmetric, bulging in some directions and compressed in others, like a balloon being squeezed by an invisible hand. One probe crossed the boundary at 121 astronomical units from the sun, the other at 119. That difference seems small, but it represents millions of miles of variation. What's causing this distortion? The leading theory is both beautiful and terrifying. Our entire solar system is moving, not just orbiting the galaxy, but plowing through interstellar space at over 43,000 miles per hour, creating a bow shock similar to a boat cutting through water. The wall we're detecting is where that motion compresses the interstellar medium, heating it to extreme temperatures through friction and electromagnetic interactions. But some researchers propose something far more unsettling. They suggest the distortion isn't just from our motion. Something out there is pushing back, something massive enough to deflect the entire heliosphere. Recent observations have detected what appears to be a region of unusually dense interstellar material ahead of us, a cosmic cloud we're approaching that could compress our protective shield even further. If we enter that region and the wall thins dramatically, Earth's radiation environment could change within a human lifetime. This isn't science fiction. This is happening right now, just beyond the orbit of the outermost planets. The temperature spike itself defies intuition. 50,000 Kelvin is incomprehensibly hot, hot enough that atoms vibrate with such intensity that electrons are stripped away, creating a state of matter called plasma. Yet the density is so low, less than 1 particle per cubic centimeter, that the actual heat transfer is negligible. The probes drifted through this inferno without damage, not because they're heat resistant, but because there's almost nothing there to transfer energy. It's like standing in a vacuum where every individual atom is white hot, but they're so spread out they can't harm you. The entire region is simultaneously searingly hot and effectively empty, a paradox that challenges our everyday understanding of temperature itself. What makes this discovery even more profound is what it reveals about magnetic fields. For decades, scientists assumed the magnetic field inside our heliosphere would be dramatically different from the galactic magnetic field outside. Like oil and water, they shouldn't mix. But the data showed something unexpected. The fields are nearly aligned, almost parallel. This suggests something remarkable. The boundary between our solar system and interstellar space isn't a wall at all. It's more like a membrane, permeable, blended. Energy and particles flow both ways, creating a dynamic exchange between two cosmic realms we thought were completely separate. The wall of fire isn't keeping everything out, it's filtering, selecting, allowing some particles through while blocking others based on energy levels and magnetic orientation. This selectivity matters more than most people realize. Cosmic rays, high-energy particles accelerated by supernovae and other violent events across the galaxy, are constantly bombarding our solar system. Most are deflected by the heliosphere, but some penetrate, their trajectories bent by magnetic forces, spiraling along field lines until they reach the inner planets. Recent studies suggest these cosmic rays might trigger cloud formation in Earth's atmosphere, potentially influencing climate patterns over geological timescales. If the wall weakens and more cosmic rays penetrate, we might see changes in weather systems that have nothing to do with human activity. Ancient climate shifts recorded in ice cores show correlations with periods when the solar system passed through dense regions of the galaxy, exactly what we're approaching now. And here's the conspiracy that space agencies don't advertise. The probes are dying. Slowly, inevitably, their power sources decay. Plutonium-238 generates heat through radioactive decay, which is converted to electricity. But half-life is unforgiving. Every year, they lose about 4 watts of power. Non-essential systems have been shut down one by one. Cameras, heating elements, backup transmitters. The skeleton crew of instruments still operating is focused on one thing: measuring the properties of interstellar space while they still can. By the early 2030s, the power will drop below critical levels. The transmitters will fall silent, and humanity will lose its only direct connection to the space between stars. After that, the probes will continue their journey in absolute silence, carrying golden records engraved with images and sounds from Earth, drifting for billions of years through the darkness. Silent ambassadors from a species that might not even exist by the time they approach another star system. But before they go silent, they're revealing secrets that change how we think about stellar systems across the galaxy. Every star creates its own version of this protective bubble. Every planetary system is surrounded by its own wall of fire where stellar wind meets interstellar medium. The measurements from our boundary provide the first direct data about this universal phenomenon. Astronomers studying exoplanets now have a template. They can estimate the radiation environment around distant stars, predict which planets might be shielded enough to support complex chemistry, identify worlds where the stellar wind is too weak or the interstellar environment too harsh for life as we know it. The wall at our solar system's edge has become a Rosetta Stone for understanding habitability across the cosmos. Recent computational models using the transmitted data have produced visualizations that look like something from a fever dream. The heliosphere isn't spherical, it's teardropped, elongated, with a tail stretching behind us like a comet as we move through the galaxy. That tail extends for billions of miles, a turbulent wake where magnetic fields and plasma spiral in chaotic patterns. Some simulations suggest the tail might occasionally reconnect with interstellar magnetic field lines, creating temporary bridges where particles can flow directly from deep space into the outer solar system. If true, this means the shield isn't just permeable, it's periodically breached entirely, allowing bursts of unfiltered cosmic radiation to penetrate regions where spacecraft operate and future missions will travel. The most disturbing part isn't what we've discovered, it's what we still don't understand. Instruments aboard the probes have detected anomalies, unexpected particle densities, magnetic field orientations that don't match any model, brief bursts of radio emission from unknown sources in interstellar space. Some readings are so unexpected that scientists initially assumed equipment malfunction, but the data keeps coming, consistent, repeatable, suggesting phenomena in the interstellar medium that current physics can't explain. Dark matter interactions, undiscovered particle types, electromagnetic effects from objects too distant to observe directly? Nobody knows. And with the probes running out of power, we might never get answers. There's also the question of what happens next. Proposed missions aim to go farther, equipped with modern sensors and nuclear power systems designed to last 50 years or more. But even the most optimistic timelines put launch dates decades away. In the meantime, our only sources of direct information about interstellar space are failing systems launched before most people alive today were born. The gap between when these probes fall silent and when new ones reach similar distances could span half a century or more. A blind spot in our understanding right when we need the data most, as our solar system moves toward that dense interstellar cloud that might compress the wall even further. And there's something almost poetic about the fact that these discoveries are happening now. Right as humanity contemplates becoming an interstellar species, we're learning that the space between stars isn't empty. It's filled with plasma, dust, magnetic fields, and radiation. It's an environment fundamentally hostile to fragile biological organisms. The wall of fire at our boundary is a warning and a preview. This is what awaits any spacecraft that tries to reach another star. Not peaceful emptiness, but a gauntlet of energetic particles, fluctuating magnetic fields, and temperatures that swing from near absolute zero to hotter than stellar surfaces depending on local conditions. Any interstellar mission will need shielding, power systems, and autonomous repair capabilities far beyond anything currently available. The probes that discovered the wall are showing us both the challenge and the possibility. They survived. They crossed the boundary and kept functioning. If machines built with 1970s technology can do it, perhaps humanity can too. The final twist is the most humbling. Everything we're learning suggests our solar system isn't special. The wall exists because physics demands it. Anywhere a stellar wind meets an interstellar medium, this boundary forms. Across the galaxy, around billions of stars, similar walls of fire burn unseen. Some are thicker, some thinner, depending on stellar output and local interstellar density. But they all exist. Every planetary system is an island in space, surrounded by its own protective barrier, isolated from the galactic environment yet connected through magnetic fields and particle flows. We're not unique. We're part of a universal pattern, one node in a galactic network of stellar bubbles, each containing its own worlds, its own possibilities, its own story. So here we are, living inside a protective shield we didn't know existed until two ancient machines crossed its boundary and sent back whispers from the other side. A shield that's weakening, a wall of fire that's thinning, and beyond it, the vast darkness between stars, filled with forces we're only beginning to understand. The probes will soon fall silent, but their legacy will echo for generations. They proved we can reach beyond our cosmic neighborhood. They showed us the barrier wasn't impassable, and they revealed that the edge of everything we know isn't an ending. It's a threshold, a transition zone between the familiar and the unknown, between the light of our sun and the ancient darkness of the galaxy itself. What secrets are waiting in that darkness? What will we discover when the next generation of probes ventures even farther? And what happens to Earth if the wall continues to weaken? if the shield that has protected life for billions of years finally fails? These questions don't have answers yet, but they will, because humanity doesn't stop at boundaries. We cross them, we measure them, we understand them, and then we push beyond into whatever waits on the other side. The wall is real, the danger is real, and the opportunity is infinite. If a pair of machines built before personal computers could discover a superheated plasma barrier at the edge of the solar system and survive to tell the story, imagine what comes next. Imagine what we'll find when we truly venture into the darkness between stars. The wall was just the beginning. The real journey starts beyond it, in the vast cosmic ocean that separates our sun from the rest of the galaxy. And one way or another, we're going there. If this revelation changes how you see our place in the universe, share this with someone who needs to know we're living inside a cosmic shield that's both protecting us and limiting us. Drop a comment with your theory about what's really happening at the solar system's edge. And subscribe because the probes are still transmitting, still revealing secrets from the boundary between worlds. The wall is burning, the data is coming, and the truth about our cosmic neighborhood is stranger than anyone imagined. What will we discover before the signals fade forever? Stay curious, stay questioning, and never forget that the edge of everything is just the beginning of something far greater.